Okay, here we have our rack and pinion, and we have our lead screw. They look pretty similar, but this one is the rack and pinion because this bottom part here slides, and that's called the rack. And down here we have a big, long screw, worm-looking shape, just like the worm and wheel, but it's a lot longer. So our lead screw and rack and pinion. Talk about the rack and pinion first. What is the type of input movement? So if I turn my crank, similar to a lot of the other systems, I'm rotating it. So our input movement is rotary. Now the output movement, though, it's pretty similar to the cam and follower, where this is moving up and down, but if I rotate this once, it doesn't fall back into place until I rotate it back. So it's not quite reciprocating, but it is moving in a linear direction. So this output movement is actually linear. We have, if I were to make the gear on top here, our input gear, larger, this is going to move the rack farther in one rotation. Right now, in about one rotation, it moves about half the rack. But say I made this gear twice as big, we would move across the entire rack in one spin. So if I made this larger, it would make the rack move longer. Is direction of travel reversible? So yes, I can turn this in two directions. It is reversible. The flow of power reversible. If I were to move the rack by hand, can I move the pinion gear? And that is yes. Again, you can see it's turning as I'm sliding this back and forth with my fingers. So yes, the flow of power is reversible and the direction of travel is reversible. An example where you might see this is in the steering system of a car. You know, you're turning the steering wheel here, and it's transmitting that power to turning the wheels left or right. Kind of, pushes them left or right depending on which way you turn. You may also see it in, just like the worm and wheel, you may see this in lift systems, where this is kind of on the side, going up and down, and depending if you want to go up or down, this pinion gear would turn in one direction or the other. So steering systems or lifts would have the rack and pinion. Now for the lead screw, what type of movement is the input movement? So my input, I'm spinning this long axle here that goes through our worm. This input movement, again, if I'm rotating it, is going to be a rotary. And the crank doesn't quite fit, so I'm going to spin it in my hand. But this is a rotary movement. What is the type of output movement? Same as our rack and pinion. I'm spinning this, and this makes this middle piece here move out a little bit slower, but it does move out away from me, but it doesn't come back in the same rotation. So since it takes me for this to come back, since I have to spin it the other direction, it's going to be linear again, because we're not going out and back in one motion. How many revolutions will it take for the crank to move this slider 1 inch? So if I were to lay a ruler down here, start at where we are right now. I don't know if it's hard to see this, but we have our 1 inch right here. So for us to move this slider 1 inch, we're going to spin, so we got, so we're at the start. 1, 2, 3, 4, and a 5th one. Okay, so we move, it was about 5, not exactly 5, but about 5 turns will move your slider 1 inch. Again, that's a little bit slower than the rack and pinion, but again, you are getting more power out of this because that speed is not increasing. So it may take longer, but you're going to get more power. 5 turns about. Is the flow of power reversible? Can you make the lead screw turn by pushing the screw block? So let's see. If I push this, will that make the screw turn? And the answer to that is no. Because these are now at an angle versus these are locking together, it will not make each other turn. So no, the flow of power is not reversible. What is increased in the output, speed or force? So instead of force, we can also use the word torque, like I said earlier in some videos. Torque is going to be that, increased force of the output. Whatever force we get out of the output is the torque. And I just mentioned it also, since we're not increasing speed, it takes me a lot longer to crank this around a bunch of times to move the slide here just a little bit. So force is increasing. We're able to push a lot more, carry a lot more weight and force versus increasing the speed. An example where you might see this mechanism, a lot of lab equipment, if you're moving things in and out, or in the woods class, with woodworking on a table, you may have a vise kind of lock things in. To clamp things down, you need a lot of force on that, and you crank it around a bunch to tighten or loosen that force. So in a bench vise as well, where you may see a lead screw. And that's all we have for the lead screw and the rack and pinion.